Right, moving on to our last two, 6 and 7. Again, we have a graph, and we're going to use the graph to get our sequence of numbers and use that to write our function and answer the question on the end. Okay, this one, again, you need to get the coordinates for these points here, and get them going, see what the pattern is. So let's start with the first one. That has an x value of 1, and it's looking like a y value of 81. 2, the second point here, looking like the point 2, 28, 27. We did look at this in class, and we realized it was 27. Our next point here is 3, just under 10, so 9. And then our next one would be like 4, 3. And so these are our points here. And if you look at the y values, that's the sequence that the change is going on here. We got 81, 27, 9, 3. Well, that's just a pattern of dividing by 3 every time. So the pattern of dividing by 3 every time, if you're trying to write the common ratio, is 1/3, because you're multiplying by 1/3. That does the same thing as divide by 3. Our initial value is going to be 81, because that's what it is when we start out. So we got the two pieces of information we need to write our functions here. The recursive one is a sub n equals a sub n minus 1 times 1/3. And then a sub 1 equals 81. The explicit function is going to follow the geometric one, because it's a geometric sequence. You're multiplying every time. Initial value times your common ratio to the n minus 1 power. And then it's asking what is the decay rate, and the decay rate is what you're taking away every time. And you can express it as like a fraction, a percent. You'll most of the time see it as a percent. And when you multiply by 1/3, you leave 1/3 of the number, and so you have to take away 2/3 of the number. And so your decay rate is 2/3, or 66.6 repeating percent for your decay rate. Moving on to number 7. Again, you need to get the coordinates here to figure out what the sequence is doing. It's looking like our first one here is the point 1, 1. And then we'll have 2, 2, 3, that one looks like 4, 4, that's probably close to like 8, because it's between 6 and 9, closer to 9. And then our last one here is 5, looking like 16. So look at your y values here for your points. We got 1, 2, 4, 8, 16. Well, that's a pattern of times it by 2 every time. And since we're times it by 2 every time, we have a common ratio. It's a geometric sequence. Common ratio of 2. A sub 1 is going to be our start value, which is 1. We got the two pieces we need to write our functions. Again, the recursive starts with a sub n equals a sub n minus 1. And then you're timesing it by 2, because you're taking every previous term. You take the previous term, times it by 2 to get the next one. And then a sub 1 is going to be your initial value. And put that there on the end. Explicit function is going to be f of n equals, and remember this is the geometric one, and so you got initial value times your common ratio to the n to the minus 1 power, and there's our explicit function. And it's asking what is the growth rate. Again, that's like what you're adding each time, and for each term number, it's looking like we're doubling it. So our growth rate is 100%. And that's it for that one.